My name is João. I'm the Director of Engineering at DefinedCrowd, and it's a big pleasure to be here presenting for all of you. So, how many of you have tried to use speech recognition?
What's the buttons?
No, they installed voice recognition technology and us left the hell of it.
Voice recognition technology in a lift in Scotland. You ever tried voice recognition technology?
No.
They don't do Scottish accents.
11.
Could you please repeat that?
11.
11. 11.
11.
Could you please repeat that?
11.
Whose idea was this? You need to try an American accent. 11. 11.
That sounds Irish.
Doesn't it? 11.
Where in America is that? Dublin?
I'm sorry. Could you please repeat that?
Try an English accent, right? 11. 11.
You for the same part of England as Dick Van Dyke?
Listen, you're saying smart ass.
Please speak slowly and clearly.
Smart ass.
11.
So, how many of you have bumped into this issue? I see 1, 2, okay, a lot. And one of the things that we'll explore here is why that happens and how can crowdsourcing and machine learning be combined in order to help solve these sort of issues. So nowadays, we see speech technology everywhere. We see big companies like Amazon, Google, Microsoft investing in speech and delivering several products like Amazon Echo, Google Now. We see speech recognition in our cars or even in our kitchen to get us to know our recipes. Why? Because speech is the most natural way for us to interact. So companies are trying to achieve this natural interaction that we have among humans, but with machines. So machines are now starting to understand us. We have things like we see in Cortana, in Siri, where we can ask to go on a date with her, but usually she doesn't like me that much. We can also do scenarios like if I want to go to a movie and if I ask, I want to see Star Wars, instead of having to say several commands, the reply I get is, okay, there's some tickets available at 9 p.m. in your favorite cinema. Do you want me to book it? So, and in a single sentence, I can get my intent accomplished. The machine learns what is my intent based on data, okay? So, as you told me, speech is not yet perfect. We're not there yet. There's been some developments in the past years, especially with the use of deep learning, and we're seeing tremendous achievements in this area, but we're not there yet. And one of the problems is that we need large amounts of data, but not just any data. If we want to have a new language, and for example, I'm a Portuguese native speaker, so I want to interact with machines in my native language. My English accent is not, it's far from perfect. So I want to use my native language. And for each language and product, I need to get all of these. So thousands of hours of speech recordings and transcription, hundreds of words of pronunciations, language variants, semantic annotation, etc. So this has a huge cost. And this not only applies to speech recognition, but also for several AI scenarios and machine learning scenarios. So where do we stand? we have a platform that allows you to enrich and train your data for AI and combine crowdsourcing with machine learning. Okay, let me explain you how does that work. So I actually been in Louis' shoes. I've been a speech scientist. And when I wanted to test the Chinese acoustic model for Mandarin speakers in Singapore, this is what I had to do. I would have to hire a vendor. I would have to hire a project manager, maybe a developer. And in the end, what I would get is, well, not very good data. I wouldn't know who has given me that data, which were the persons, and I would have to wait a lot. So what we introduce is a model where you subscribe to our platform, you select the job type you want to do, and you launch the job, and the crowd takes care of it. We use the power of the crowd to achieve this. And in the end, we come up with much better data, high-quality data. We provide transparency, and at a much faster rate. So the client, the enterprise client, can come to our website and select what type of task he wants to do. These are tasks that relate to speech technology, like semantic annotation, data collection. But the good thing is that you can have any kind of task configured in our website, and you can achieve any kind of machine learning scenario. And how do we do this? We use students all around the world. So our crowd are actually students. And we have language ambassadors that have a nice worldwide coverage and allow us to access multiple languages and also access crowds in multiple countries. And we know a lot about these crowds. So we know what courses they took, so what is their expertise. We know what languages they speak, what jobs they took, and how they performed in the tasks, in the micro tasks that we need to do in order to reach a better speech technology. So, but how can we use this data? How can we use machine learning in order to take advantage of this data? If we have activity from the users, if we know all of this, what can we do? So one of the things that we can do is that we can learn from this data in order to provide recommendations to customers, and crowd members as well. We can help the crowd to perform their tasks, to be more efficient in their tasks. There are some tasks that we cannot replace the crowd, but we can help them. We can provide suggestions. Imagine that someone is doing a repetitive task for a long time. What happens if they get tired? Well, maybe the quality of the task will not be that good. Can we detect that using machine learning? What are the patterns that people show when they're tired, when doing certain tasks? We also can model how we want to measure quality. In our case, what's important for us is what were their qualification scores? What were their performance when using real-time audits or reviews? What is the comparison between their opinion and the opinion of others? Also, what is their expertise? Is this an expert or is this a non-expert that is accomplishing the task? And very importantly, we need to understand how subjective is the task. Because, for example, if you're asking someone to pick their favorite color, then expertise doesn't matter because it will be different for everyone. And it doesn't matter if you're an expert in colors. Everyone will have their favorite color. So let me give you an example of how this works, going into practice. So we have raw data, like I told you. And then we can transform this data, extract characteristics of this data, and classify it, and understand it. So I have here a very, very simple example. The graph seems complex, but I want you to focus on the difference between the box plots. These box plots represent statistical measures. It doesn't matter which measures they are. And they're based on a generic measure. Let's call it measure A. And notice the difference between the box plots. from here, we can already see that this member, which executed the tasks, presents significant differences regarding all other members. So let's take another perspective. If we try to separate the data from different crowd members, what do we get? And this star that is represented in blue was this guy here. So we have the data from all other crowd members, and we have the data from this speaker. And this was all done based on unsupervised approaches. So there is no previous knowledge of what has happened. And we're able to split the data. And when we investigated, this is real data, by the way. It's a sample, but it's real data. And when we investigated this member, what happened is that it showed that the quality, that the input that he provided was not that good. So what do we want to deliver to our clients? Is that we want to deliver all the data, or you just want to deliver the best data, which is crucial in examples such as speech recognition? Okay? So what happens if we add another measure? We can say for certain that this member, the data of this member in green is not that good. The one in blue, I would say that we have doubts, and then we can extract confidence measures on the data of the members, on the logging data of the members, and probably you just want to deliver the data in red to the customer. So what else can we do? How far can we go with machine learning? Well, we can try to understand what is the expected quality of a task based on the configuration a client gives, based on the crowd that he selects, on the speakers, on the crowd members he selects. What is the quality he will get in the end? And we can also calculate the trade-off between the quality, the time, and the cost of a certain job. So additionally, we can predict when the job will finish. So a customer can go into the platform, can select a job, and he gets to know what type of data he will get, how much quality, and how much he will spend. And he can measure those trade-offs and when he will get the data as well. Additionally, we also try to find the best match between the job and the crowd member. Okay? So this is just an example of how we can use machine learning in order to improve our tasks within crowdsourcing. And speech technology is just an example of what we can achieve. I think I published the first paper on crowdsourcing in 2009. It's amazing to see the evolution that we got so far and how big crowdsourcing has grown. And machine learning is going through the same process. It's also growing. So it's two areas that can complement each other and can add extreme value. Thank you.